Hi, folks. Today we're here with Caleb, aka Zydron, actually. He's going to give us a class in generative art, and he's also on Mintbase with his arts. Check them out, they're awesome. And today we're learning a bit about P5JS to use to create generative art. Hi, Caleb, Zydron, how are you?
Hello, Clara. Very nice to see you here. I'm very happy to be here. I want to say thank you to all the Metaverse DAO members
Thank
and
you.
and the near community also for this event. Yes, it's a big pleasure to be here and talk about generative art. And yes, thank you. Yes, let's start. So
We're very excited.
I will start. I will share my screen. I created this little presentation about the generative art. In fact, last week I was giving a class, this class, more or less, but in Portuguese, at the other DAO, Gambiarra DAO. They have this proposal about the anti-method, this classes, weekly classes online, and I was the last class from the last month, and then I was everything ready and saw the opportunity at the Metaverse DAO and subscribed my proposal there and was very happy to be selected and translated to English. It's my first class in English, so sorry for something about my English. I'll try my best.
You're going great.
This is my first generative art collection at Meatbase. This is my collection. I minted 4 pieces. I have 16. Only one of one. I put a very low price because I'm beginning there and I want the collectors to can buy cheap and sell fast, like. And I have 4 now, 3 sold. I will mint more the next week. This collection called Just Another Abstract Composition at Mintbase. The link is there in the chat. Okay, yes, let's go. Generative art, yes. What is generative art? Yeah, for you, Clara? What do you think? What is generative art for you?
Well, what I understand of it is, art created by code. And the code, every time you access it, the code generates another art. Is that it?
Yes, you are right. Really right. But not always the generative art was made by computers. In the beginning, maybe the definition was different, but I have a little bit different. I was trying to make, but this definition is the most common definition. Art made by computers is not everybody say this and is right, yeah. But today, almost 100% of generative art is not 100, no, but 80 is made by computers. But maybe it's more like art generated by rules, some kind of set of rules. Uh, Sometimes you can have the human interaction. Sometimes not. Maybe yes, maybe no. The human interaction, human with this output. But normally no. It's just a set of rules and you have thousands of outputs in this of these images. And if you want more versions, you need to input more chaos in this code, like more randomness, more noise, and you have more more different, more results. You can have different results. So yes, maybe just set of rules. But I was researching like kind of about yes, what the story of generative art, where the beginning, and then I was trying to discover who is this artist, the first artist to make generative art. And then I discovered this Eduardo McIntyre from Argentina. Was an artist in 59. This guy was making this, create the term, the first generative art. He released this time.
Wow.
This guy from Argentina, Eduardo McIntyre. And write down a manifesto in 59 of generative art. And also create a painting group and expositions calling generative art. So in 59 was the fashion, like was the hype, generative art in 59. And this guy came to Brazil also, to MASP in São Paulo, exposed the Bienal. This is the art of this guy. And this link here is like the rules, the set of rules he developed to draw. His drawings is like a set of rules in which you can do it if you follow all the steps to make these drawings. It's just a set of steps, yes.
That's awesome.
This guy, McIntyre, so I think was very cool. Yes, I have this little fragment of text I taken was this definition of generative art from McIntyre. It's like, I will read here, consists of the work starting from a point or straight line to generate motion by successive shifts, rotations, and vibrations through the plane. So this definition is very, this kind of drawings. People can find more about the McIntyre and the generative. Yes, then moving forward, the first computer art guy, this German guy, Jörg Niss, in 65, he started to the first computer art in a gallery. Like this kind of made by computer codes. Very old computers making art. The first computers trying to make art. Really beautiful, this kind of drawings. When I make my first generative class a few years ago, I developed some code very like this drawings, but I never saw this before, but very beautiful, these wrong paths. So this Jörg Niss is 67, 65, and then just this pre-story of generative art, they have the Mandelbrot writes down and develop this math, and the result of his math in the computer was this draw.
That's gorgeous.
This math formulas, Benoit de Mandelbrot, the fractal geometry of nature. We create this term fractal, and all developed by computer. This code is translated, this mathematical formulas to computer code, and the result was these astonishing drawings. Hello, Camila. So yeah, 75. The computers was a little bit better than have these fractals, just very fast here. Don't want to. If you can have it at P5JS website, you can see these examples of the Mandelbrot fractals there, have code. I will show you later. And then have Kim Perlin developed this noise algorithm and was a revolution. And for like the movie Trons and computer graphic games start to develop these graphics, just first the simple code who can make clouds, mountains, terrains, the noise algorithm, and this noise we will see in the code in the practice. In we will code with noise now later, a little bit later. But yes, Ken Perry, just doing this prehistory, and then 83, okay? Then a little big jump, 2001 processing came and was the renaissance of generative art. The computers, technology, the computers was faster, and processing was this software, code language, programming language, and community develop thousands of lines of code, free code on the internet, and you can learn how to code there. Processing, I learned a lot. I started with processing more or less in 2010. And now processing is 21 years old community. And it's really nice. Yeah, I will teach you the basics of P5.js today and processing. But more, P5.js is the part of processing. The original is Java, Java language, programming language. And the P5.js is the part of this programming language to JavaScript. So, okay. Later I will teach you a little bit about the P5.js. I just wanted to talk a little bit about the generative art at the blockchain. Because, yes, it's the new hype. Generative art is the hype. The first two big projects of generative art in the blockchain, CryptoKitties is very successful NFT project, and is generative art. It's just a set of rules generate the kitties. So it's beautiful kitties. Millions of dollars. I don't know the numbers of the CryptoKitties, but Dapper Labs, 2017. And then the same year, the CryptoPunks collection, also generative art at the blockchain. The punks is generated by codes, not. You have the traits of each punk, and the people. Some punks was generated before, but some people buy and don't know the result at the moment of they do this. So yes, it's generative art, and the most successful projects, the punks today, millions of dollars. And it's generative. I think these guys, these programmers at Lavoura Labs and Dapper Labs are amazing programmers. So I think genius. And okay. And then later we have the artblocks.io. I don't know Artblocks because it's the first, this here the definition. Yes, it's processing on blockchain. Most of the projects on Artblocks is processing, is P5.js. So 2021, very later, but on Ethereum. So, but this is a curated collection. You as an artist, you can apply to put your work there. You need to be selected. But you can, if you wanted to apply, you can go to Discord of Artblocks and see the schedule to apply. So we can, it's this way. And we have very successful cases like Monica Risoli. Let me show you here. I need to show you the Monica Risoli works at Artblocks.
She's awesome. I love her.
Yes, I love her also. She's a success there. Was sold out in very fast. And there is need two artists. Jacob Case, Mapan, Rias. This is the creator of processing. This guy, Rias, is the one of the creators of processing. And where is Monica? I wanted to show the collection because it's very beautiful. Wait. Marcelo Soria Rodrigues, amazing. Fernando Gés, where is? Lá. Caça. Cadê? Cadê? Não aparece, vou procurar aqui, peraí. Artblocks. Monica Risoli. Cadê? Não tá aparecendo aqui. Bom, não consegui deixar preparado aqui, mas depois a gente acha aqui e eu te mostro. Vocês podem procurar com mais calma aqui. Aqui, pronto. Chegou a coleção dela aqui, ó. Então, todos esses artistas, all these artists here, this is the collection found. All these artists here was curated by the artblocks.io and sell very well all these arts. So it's very beautiful, the arts of Monica Risoli. It's one of the most renewed collections in generative art today. Okay. And then continuing, this other market at Tezos. Other markets at Tezos, I sold my art at Hiketnank. Teia, now is Teia. Hiketnank was discontinued. And now have the Teia community have his own smart contract there on the Tezos network. And yes, you have a lot of generative art there. A lot. And I sold a lot there also. Have my art there. You can follow my Zydron there. Teia.art. Hiketnank is more or less dead, but was a Brazilian guy who made Hiketnank. Was revolutionary guy, Rafael Lima, code the Hiketnank smart contract and explode all around the world, all the artists around the world using is one of the biggest markets outside Ethereum. And then after that, we got the FX hash XYZ. Cyphered is the guy who coded this platform. When I started this in this platform, it's like artblocks.io, but open. Everybody can input the projects there. It's not curated, so it's more open, and it's Tezos. Tezos is cheap, it's like near. You can mint very, very cheap, and Tezos also is nice because of this. And yes, of course, you can have generative art at Mintbase also. Lots of arts from Hicket Nunk. Now all arts also going to Mintbase and minting there, generative art. And other the Paras also. I didn't start at Paras, yes, but Mintbase I saw a lot of generative art, including from FX Hash. Yes, I love the FX Hash. Yeah, I think, yes, we need something like that in here. And yes, let's code. Live coding. Let's do some live coding here and let's code some random and noise. I wanna show you the open processing. Here is my link. I have hundreds of code there. I use open processing all this time from the beginning. Now I'm really a premium user at this site. I can hide my code. But okay, I will show you how it is processing and P5GS now. So if you can go to open processing, you can create your own account there if you wanted to code with me. And you can, is a repository of code, processing code. You can learn a lot here. You can, because it's open source, you can learn and you can change the code, and it's okay to change the code and create your own thing with this code. It's not cool. It's not cool to take this code, copy and do like people do, like copy minters do it. It's not cool. But you can use the code and create and make this code your own, change. So, but I will show you here how it works. Open process. You can create your account, and you can save online all your codes for free. So I will create a new sketch here, and I will save and put the name Metaverse class. Later you can come here and use this code. First, I will just look. This is what's happening. I don't know if you know processing, Clara. You use a little bit of processing, more or less. Camila Kamoff is here. I know she know a little bit also. Okay. Here is the first, when you create something new here. Here is the thing who open this way. So I'll show you this code is doing this. You can just click this button here at the side of the triangle play, or click here or play. Play just execute the code. When you press play, the code is being executed. So you can see it's very simple. It's just 8 lines of code to do this. And the first line is this function called setup. The setup is like what you need to start your program. Everything you need to start the program need to be right down here, the code. And this code is executed just one time. When you press play or start the program, execute these 2 lines. And then never again. Just one time. So this, in this case, is create canvas, is to define the screen of the program, the size of the screen. And receives 2 numbers here. is like the width and height of the canvas of this depends of the window of like here is web. JavaScript is more focused on web. So you are on browser, you have windows, like in code, like when you programming HTML, you have windows, you have this kind of thing. So it's the window, like when I press play, the windows now is all this space, but I can, if I do this, now it's different, it's a different size. Okay, I can do lots of this size, all the sizes will work with this code, yeah. This window width do this, but you can put like a number, like 400 by 400. So the window will be very little, like, look. My screen is full HD. So, but I like this is better here, this way. And then this creates canvas is like in process, this in open process, we are using P5.js now. In processing, this word will be size, not create canvas. Okay? Just this difference. The same thing, but size to define the window. And then we have the background. This is the color of the background. When you put one number only, is the grayscale colors. You can put 0 and you have the black. 0 is black and 255 is white. This is the first way to use colors, the easiest way, or the first way. Only one number inside here. But you can have the RGB system here, RGBA, like red, green, blue, and alpha opacity. So if you 3 times 255, R is maximum. After G, 0, B 0, and can put 50% of the opacity in the background. This is not work too much. Forget about it. Just this 3 colors, just green, red. Just use the red at the background because it's the right way. Or one color, you can put RGB or HSB or even hexadecimal code. You can use lots of ways. Like I can use the shows a color, put you have a variable for color, but just to start this way to understand the colors here. Then we change. Well, I will put 0 for keep clean. And now we have the second function at processing P5.js is function draw. This function draw is where your animation lives, where all the code logic of code is here. Where your program lives is here, inside these brackets. In this program now, it's very simple. It's just a circle, just a ellipse. Okay, we saw there. Then I can put this at the side. It's just an ellipse, okay? But what's happening? He is drawing one ellipse in each position of the mouse because this function circle receive three numbers. The first two numbers is X position, and second number Y position. The third number is the size of the circle. So this is what happened in this code. Only this. Mouse X returns the mouse X position in the window. Mouse Y returns the mouse at the Y axis. X axis, okay, very simple. Okay, let's use the random. I don't know if you know random, but I will make the ball stop this ball at the center of the screen. Just put the ball stop there, in the center of the screen. This is, you can use widget. We will return the window widget, the size of window, in pixels. In processing, the positions works in the position 0, 0 is here, and on top left. And now let's see. One ball in the center, okay? 0, 0, when you use the 2D is top left. So in the center. Now let's put some randomness in this position of the ball. Or we can change or use the other primitive geometry, but if you want, yes, let's do it later. Yeah, let's do this, but okay, let's use random only for the width. So we can write random. Random, you input a number, we return a random number from the 0 to this number. The first way to use it, if you input only one number, like this. The ball is moving. Just 10 pixels per second. Now, in fact, it's because the draw works like is 60 times per second. It's drawing, the frame rate is 60 times per second. So it's 60 balls per second, like. But in random positions, you see this, and you see the trail behind. It's not removing the background, because the background is right down the setup. It's just one time. So you see all the balls is painted in the screen. I can just change this to the draw. I cut and paste the background inside the draw now. Now you see, don't have more the trails. I will put more here, 100. Now you see the movement of the random movement at the x-axis. Okay, same 100 pixels, 60 times per second. Okay, we have some. I will keep simple for now, but we can do more later. I will leave this random here and show you the noise, because we don't have too much time. I will show you the noise and then we go refine in the sketch. But I have other, just for you understand the noise now. Now, I changed put this ball a little bit up in the screen. Here, yeah, I'll make another circle. But using noise. Noise is, you need to use a few more little bits of code. Noise, you write noise, but noise, you need to keep adding a number inside noise. And I will use a function to do this. This function is called millis. Millis. This return the time, amount of time my program is running. Is a number always, but is in milliseconds. So in 1 second is counting 0 to 1000 in 1 second. Okay? More or less. This millis is like a clock. It's like a clock. It starts to count when you press play. I don't finish the code. Is crying here a little bit. But let me see. I thought is missing. Here. But I didn't finish it. But this, is a very big number. This millis function returns this amount of time in milliseconds. So in 1 second, this number is 1000. 2 seconds, 2000. It's a very big number. The movement is very fast this way. But here is making, but from 0 to 1. Now it's moving, but we are not seeing because it's 1 pixel only. We need to multiply this number. Like here is 100, okay? We can put 100 also. But you see, it's very fast this time. And I want to divide this number, make this number little. So we multiply for a very little number, like 0.0008, a very little number. See, and we have a more organic movement here. This is the noise. So I using this function. Noise work this way. If you wanted to know how to work any of the functions here, you can use the documentation of P5JS also. It's very cool. The documentation of the P5JS, you can learn a lot there. But here you can see a little bit the movement of the noise at x-axis and random at x-axis, the two 100. Okay? It's very simple. Look, 10 lines of code. We can do, it's very beautiful. Just this for you see the difference. But yeah, we can make a lot of things, different things. Now we can do the same for the y-axis, and you have the more movement. Like just this. And the same. We'll copy this part of the noise. And the position, we'll just for better visualization here. Let's see. But just one thing is not so good in the noise, because the noise, look, is the same number, okay? This is not so cool because you have the same number in the x and y axis, so they make this movement go back and forward the same. So you need to change the number a little bit in the seed, the noise seed in the y axis. You can just input a big number here inside before, like big number. Oh, wait. Plus, you have a big difference. Now the x and y axis on the noise algorithm is different, and now you have this organic movement. So just so very nice. Now one thing is leave the trail, put the trail. When now the background is being painted 60 times per second. We can make a background with opacity. Like, let's try to do this a little bit more nicer, like, because, okay, we understand how to use random and noise. It's not so beautiful yet, but it's the way to use. You can do a lot. Like, what you can do this here is like, let's leave a trail. I will write down some code here, like no stroke at the geometry. I will make a rect 0, but before the color of the rect will be the background color, like 0. This background I will put again here, paint one time the background 0. Then no background here like before, but a rectangle, the function called rect, is almost like the circle. It's 4 numbers. The first 2 numbers is the position in x and y. So I will put 0, 0. And the other 2 numbers is the size, the width and height of the rectangle. I will put the same function width. I want the size of the window. If you 0, but now I will put the opacity. If you put only 2 numbers, it's grayscale and opacity. Now I can put very more to have a slow fading effect here. Like a slow fading. Well, sorry. I needed to, because look what happened. I put no stroke, fill. Now the rect and the circle have the same color, but the rect is the background. And here also forgot the brackets, but now I need to put the other color was white, the color of the circle. White is 255. Let's see what's happening. Now a little trail there. You still have this trail effects. So this little snippet of code. Now we can, let's see.
That's very cool.
Let me ask you, everything is cool? Are you okay? And it was really hard to. It's fine. School? Like? What?
It's awesome.
You have some question or something? Somebody want to ask something? Or
Okay, it's okay.
nice.
Good too.
Was really hard to understand this noise function here. This very few words and numbers. This is very cool. Yeah. Now it's 100. If you want to, the amount of noise will make the amount of movement in the x and y axis. Now it's 100 pixels. We can input here like width divided by 2 is like half of this window, and here can be half of the weight of the window, half of the width of the window, half divided by 2 is half. And now the movement is bigger, starting from this point, have this bigger movement. Okay, and here the same, you can put in the random how much, let's see, not all the screen, just so aqui less, a bit less. So I made something more elaborated here with this, more or less this algorithm. I will save this first version. You can improve, you can come here and fork this code, make it yours, and code something. Like we can, now we can do a lot for real, yes. You can, like, you can make lines, something. Let's try to do something fast to make it better. Like we can, don't use the fill, use the stroke here. Like use the stroke only, in no fill. Stroke and no fill. You can do more or less with the size. Now I wanted to input this different colors. Do the like noise on the color. You can do the noise on the color. Like just copy this, but you can start in the middle, like 25, put plus noisy, multiply 125 to go to the same velocity, and you can choose a color like blue. So 0, 0, blue. RGB. Random colors, yes, random colors is classic also. Random. Here. Ah, the color is not changing too much. We can use here the HSB color mode. Is cool because at the HSB color mode is only one number to run through all the colors. You can put 200, 200. And color mode, I will keep the color mode RGB here. Is this the sequence of lines defines the drawing. So here is I want color mode RGB, and from here I want the other color modes. HSB. HSB, the hue is the first number, saturation bright. The first number will change the color a little bit more. Oh, wow. We'll put this here. The color RGB from the beginning. See? Now have a little fade in the colors, change the colors using the noisy algorithms. You can change the size also, the 20 pixels the size. You can also use again not just to change the size of the circle. Wait. Yes. 1, 2, 3 numbers. 3 times noise. I made it a better example here in the last class. I didn't comment too much this code, but is it more or less? What you wanna ask? What you wanna ask something? I wanna show you the other example a little bit more the same
That's
piece.
so pretty.
Oh, thank you very much, everybody. Choice.
Fonseca is asking if you're going to share this code. Yeah.
This is shared. I will put it here now on the in my profile at Open Processing. I have lots of code there. I have also another repository of code at sketchpad.cc. I will show you here. Oficinaprocessing.sketchpad.cc. Also, you can. I have a lot of code shared there. Let me put here. But yeah, my profile. Have my profile. So here in my profile, I will share the presentation also. A save. Let me save this here. Like, let's think a little bit. Let's try to just do it better. It's not so nice yet, but let's see. Just to displace the random ellipses, displacing all the screen. To do this is only input random width and random height. So the position will be random in all the window. And Okay, the other one, this is, let me show another, this two slashes is comments. So here is something just to write down to remember later, explain the code for yourself and for others. So this two slashes is comments. The, the, the words you write after the slashes are ignored by the code, by the program. And you can just write down some information like the random circle, this code. And this other code, noise circle. So you can understand later. You can remember what you write down. So yes, yes, it's okay. This example, like the circle random, is like they call pointillism. Pointillism in processing. It's very classic. And now let's try to make the ellipse is read it by 2 height. Well, that's is, I think that's the way. Or yeah, start on the center and then they made this organic movement. Okay, let me think. Somebody want to ask something more?
I think we're all paying close attention to what you're doing.
Very nice. Oh, it's really nice. Let's see. Yes, now we can do this movement, like this algorithm, for anything, like you want to make lines or triangles or rotations. It's really cool. You can just like if you I change to rect here and let's see. Need to put 4 numbers. Now it's 1, 2, 3. You can apply to rotations. This time direct just to fix here or it's really cool. Apply the rotations also. Here, wait, I need to input 2 times. Leave this rect in the left top. Now I forgot. Just fix like this. Oh, in the rect mode center, the position of the rectangle is the center of the rectangle, not the top left of the rectangle, like the. So I'm using the center for because.
I'm sorry, he stopped the recording by itself.
Okay, very nice. Let me see what's more can I do here. Yes, the rotation. Just to maybe to finish. If you wanted to ask something more, and I will show you how to use the rotation here. It's a little bit more, 3 lines of code more for you can do this. Like you need to, but I'm in the end. This is push to save the state of the matrix here. Push and pop matrix. You need to do this, always need to push pop. And save the state of the matrix of the positions. For one position, don't the rotation of one thing don't apply in the other, you need to use these 2 lines of code. And then let's apply a noise inside the rotation. But here, this noise needs to multiply to something. I missed this last part. Multiply, but this time to an angle, 2 pi. It's like because it's in angle, you need to write down in angles. Or, okay, you can just write down a little number, works. Oh, no, something little, just, is out of the screen. Can just fix here again. Let's see. Fix this position, but it's not the right way. So it's a little better way to do it. Let's do it the right way. The right way is use the translate here. Ctrl X here. We put the positions inside the translate. The right way to do in 0, 0, 0. Up, on. Yes. So it's more or less these things I wanted to show to you. Now you have the noise rotation. You can fix now the position here, like if I want a little bit, try to center. Well, that's it for today. I hope everybody like it. I can leave more trail here in the opacity. I can put a little bit better background background color. But cool. That's it. If I wanted the movement to be slower, is a number, little number, like divided for a very little number. Like they go very slow and understand the movement. This rotation in this case was more slow, but if you wanted the X or faster, if you want faster, is a bigger number, like nice.
That's so cool. Fonseca has a question. He asked, is it possible to export a frame as a static image?
Nice, yes.
Yeah.
You can export a frame, yes. It's very simple to export a frame. Let's do this. One simple frame, or the GIF, or or make a video. Sometimes I prefer to use the OBS to save a video, because it's faster. You can just configure your browser and record your screen, and later do the GIF. but have a library for GIFs. But if you want only a PNG or a SVG, it's very easy also. You can use the kpress and write down a function. Right, I will write here very fast. Kpress it with the, if I press any key on the keyboard, I have this native function from P5.js, so you can save and put a name for the file, test.png, for example. Okay, here, if I press, you see, just test PNG, save. Now, save this image, okay? To make a GIF, if you input, you need to input the frame rate here for the number of frames per seconds, because you can use the frame rate, because if you input this line of code inside the draw, you save 60 images per second, so no good. Maybe, but here is okay. But also look this SVG. You can have scalable vector graphics, vectors, like very high quality files. The SVG. Test scalable vector graphics. I save it SVG. You can open this at GIMP and export a high quality file, bigger file with lossless resolution also. Okay. All the generator move or there are move, or there are some fixed. There are fixed. Fixed too. Have animation. Yes, have animation, art, and also fixed. I release a lot of fixed art, but like in the markets have animations at FX hash, or you can make the movie files or GIF from the animations. But yes, you can have animations and static, also static. You decide, so very nice, people. I want to say thank you, because we have the party now, magazine party. Clara, thank you very much, Clara. Metaverse DAO, everybody, Fonseca, Camofa, Peter Juice, everybody near protocol community. Thank you very much. I hope everybody can understand later my English. Little bit.
You're great.
Accent.
We loved the class. Thank you very much. It was an amazing class. I'm excited. I'm looking forward to try it out, because I was watching and recording. I couldn't. Thank you very much for your class. It was amazing.
Thank you very much, Clara.